Hi, my name is Adrian, and welcome to my physics presentation. Video presentation, I guess. Today I'll be talking about the motion graphs and a quick description. What is a motion? A motion is a change in position from A, like here, which states from A to B by distance. So the formula for this motion graphs is speed equals distance divided by time. So whenever you have a graph or something that you want to show, like a speed or something like that, you put the distance as the y-axis, and you put the time as the x-axis always, and always you have to do that, because that's motion graph. So all right, let's move on. Yeah, all right. So the speed, the formula for it is speed equals distance divided by time equals milliseconds, miles per second, okay? And the acceleration has to be, and the equals of the acceleration has to be always miles per second squared. So how do you know if the speed is increasing? When the light is increased. How do you know when the speed is in constant speed, like in the same speed for about a few seconds or maybe even more? This is the constant speed. How do you know? Like if the speed is decreasing? This is how you know. When the speed force is decreasing by down, the time, not sorry, but the speed will go down with the time of how much seconds it goes down. How much seconds the speed goes down, and constant speed is just staying at just one speed for about a few or more seconds, and increasing accelerating speed is when what's it called, when you have increase in speed, and it increases the speed by how much time you increase it, by how many seconds, sorry. All right. Yeah, okay, wait, let me just zoom in. Yeah, okay, I think this is good. The graph shows, this is an example that I took from one of my worksheets in Google Classroom, so I'll be describing what it is about. And the graph below shows how the speed of the bus changes during the part of the journey. Choose the correct words for the following list to describe the motion during each segment of the journey to fill in the blanks. Here you can see the blanks are filled by my tutors, which she checked today. The following blanks they have to fill in for each segment is accelerating, decelerating, constant, or at rest. I haven't explained what is at rest, but at rest is something that the car or like a person is not moving at all. It's not giving speed, but it's just staying. But it's just like staying in one place and doesn't move for a few seconds. Okay. Anyways, from segment 0 to 8, the bus is okay, let me just block this away. The bus is something. Its speed changes from 0 to 10 miles per second in 5 seconds. So you can see from 0 to 8, 5 seconds. You can state it as the bus is accelerating. From segment A to B, the bus is moving at something of 10 milliseconds for about 5 seconds. So what it's saying is like it's going at the same speed for about 5 seconds from A to B. So in this segment, you can say it is in a constant speed. For segment B to C, it says the bus is something. It is showing down from 10 milliseconds to rest, which means like from 10 miles per second, it drops down to like it doesn't move at all. So at this point, you can say it's decelerating. Okay. From C to D, the segment C to D, the bus is something. It has stopped, just stopped, which at this segment you can say it is at rest. From segment D to E, the bus is something. It's gradually increasing in speed. So at this point, you can say that it is actually accelerating. All right. So now I want to show you some what's it called? Yeah, all right. So now I want to show you some word problems from here. It's the same motion graph part. So like you can see the equations, C divided by D. Wait, let me just zoom in, zoom out. Yeah, okay. So like the equations for this following place is for motion graphs and velocity, acceleration, speed, and etc. So here you can see speed equals distance divided by time for the speed, if you want to find an equation for speed. For velocity is velocity equals distance divided by time with directions. And accelerations is acceleration equals brackets velocity fall. I think it's velocity initial and velocity. Yeah, it's brackets velocity full velocity and minus the initial velocity brackets divided by time. Yeah. Okay. Alright, let me start writing for the first question. Question number 1. The question number 1 is asking me what is the speed of the rocket that travels 9,000 meters in 12.12 seconds. So what it's asking me is asking me for the speed. So what I have to do is put the equation S equals D divided by time. Distance divided by time. That's your equation for this, for the first one. Now, you put in alright, wait 1 second. It says to me that the distance is 9,000 meters. So I can say D equals 9,000 meters. The question is also telling me the time is 12.12 sorry, 12.12 seconds. Alright, 12.12 seconds. It wants me to find the speed, so we put in the equations, right? S equals 9,000 divided by 12.12. S equals, get me out the calculator. So it is 9,000 divided by 12.12 equals 742.57. Sorry, my mistake. So it is 742.57 meters per second squared. That is your answer for the first question of this workbook. All right. Now let's move on to a bit harder one. Alright, number 3. Let's move on to number 3 because number 2 is almost the same thing as number 1. Like, the same principles. Alright. Let me just move the paper. Alright. So, number 3 is asking me how long will you trip? How long will your trip take in hours if you travel 350 kilometers at an average speed of 80 kilometers per hour. All right, here they are asking me for the time of this. So now the equation is still speed equals d divided by time. Now this time we do have the speed. The speed is 80 kilometers per hour. 80 kilometers per hour. That's our speed. Our distance is what is the distance? Yeah, it's 350 kilometers. 350 kilometers. And and they want to find the time. They don't know the time. They need to find the time to know how long will their trip take in hours. So what we do is we change the we actually don't change the equations. We put the following thing that we have, which is 80 equals 350 t. Cross multiply, which then will be t equals 350 divided by 80. T equals 350 divided by 80. Divided by 80 equals 4.375. It took them 4.375 hours to get them back to their home. All right. Now let's go to the bit trickier one. Okay. Okay, let me just adjust it. Okay, nice. So for this is question number 7. Question number 7, okay. And for question number 7, they're asking what is the speed of a walking person in miles per second if the person is traveling 1,000 meters in 20 minutes. So for this equation, we have to convert the minutes to seconds. For that, we have to time equals 20 minutes. Then it will be 20 times 60. I guess it's 1,020 seconds. Then S equals 1,000 divided by 1,100. Okay, so then it's gonna be 10 divided by 12, and then 10 divided by 12 equals 0.83 miles per second. That's the average, that's the time for the second. All right. So we found the seconds, and now we have to find the. Actually, no. Yeah, This is the average. This is the average speed for the what's it called? Wait, square. Yeah, this is the average speed for number 7. So we converted 20 minutes to 20 times 6 equals 1,200 seconds. That is how much seconds there is in 20 minutes. So then we adjust the speed equals 1,000 meters, because that is how much meters they told us in question number 7. And then divided by the seconds, which is 12,000. 1,200, sorry. Then you simplify and you take out the zeros, which then will be 10 divided by 12. Which then you convert, what's it called? 10 divided by 12 equals 0.83. So we can put here as going on, which is the same answer. Alright, I hope you liked my presentation. This is my last one, and I hope you liked the presentations and everything, and descriptions of my physical science, and I'll see you next time. Thank you.